Thank you, Muriel. And I want to thank Carlos and Ivan and John for setting the stage today, giving us a broad view and a detailed view of some of the things that are going on. We have 2 days of really interesting conversation ahead of us. And we wanted to start today by hearing from 3 national experts who can sort of lay the groundwork for us. We're really excited about these 3 experts. First of all, we're going to hear from Parimal Kopardekar, and commonly known as PK. PK serves as the director of NASA's Aeronautics Research Institute. He's responsible for exploring new trends and needs related to aviation in the areas of autonomy, aeronautics, manufacturing, and advanced air mobility. He also serves as NASA's senior technologist for air transportation systems and is the principal investigator for the Unmanned Aircraft Systems Traffic Management Project. After PK, we're going to hear from Michael Huerta. Michael is recently completed his term as the administrator of the Federal Aviation Administration. He is currently a senior advisor to Macquarie Capital and a member of the board of directors of Delta Airlines. He's well known for eliminating the decades-old ban on the use of portable electronic devices aboard airplanes during takeoff and landing, making it possible to use many devices from gate to gate. And I personally offer my thanks for that, which made travel a lot more convenient and comfortable. As Carlos said this morning, we want to get on an airplane and lean back and just get to our destination. And Michael helped us get to that point. Finally, our third expert today will be Steve Kuciemba. Steve helps coordinate ITS projects and resources for a wide variety of clients and disciplines, while also continuing to lend his state of practice expertise to project work at WPS. His ITS background spans a variety of technical and policy program areas, including infrastructure-related ITS deployment, connected and automated vehicle systems development, coordination of incident management and transportation management centers, travel information business models, and legislative outreach activities. So we look forward to hearing from each of these 3 experts. And now we'll turn the time over to PK to get us started.
All right, great. Thank you so much. Blaine, can you hear me okay?
Yes.
And can you, would you like me to do my slides, or you want to do it on your end, or either way is fine?
I think if you, well, let's see. I think you were going to do your own slides, right?
I can do it from my end.
Okay.
Our team has them as well and can pull them up for you, PK, if you'd like.
Sure. Yeah, here we go. Hopefully you can see the slides. Can you see? Yeah, can you see my slides? I'm sharing them now if it works out. Can you see the slides?
Yes.
Okay. All right. I'm really pleased to be here with the distinguished panel here, and happy to go through the NASA's current activities focused on advanced air mobility. So this is sort of OV1 operational view that focuses on advanced air mobility. And the reason I like to just start off with this slide is it is not just urban. Initial thinking was urban air mobility, but then as we started to go into the details of the needs and different aspects of air mobility that is required to support different use cases, we realized that it needs to have expanded view, and we started to call advanced air mobility. So you can see that there is a cargo delivery, you can see urban operations, obviously, but also a lot of rural, suburban applications, such as medical transfers and cargo outside, as well as connecting localities that are underrepresented, underserved, and underconnected in today's world. We are also looking at some interesting use cases such as wildfire, where we can actually serve some public good as well. So again, the idea of advanced air mobility is to reach to those places by aviation that hasn't traditionally seen aviation. And that could be many types of vehicles, from smaller drones to larger electric vertical takeoff and landing, as well as electric short takeoff and landing. So creating that safe, sustainable, affordable, and accessible aviation is really one of our main passions. If you look at the urban air mobility and then extension of that to advanced air mobility, you start to see that there is a vehicle or aircraft side perspective and the research and development that's needed to make sure that aircraft produces as low noise as possible. It's very reliable. It can operate under different conditions like GPS degradation and such. It's quieter because of electric propulsion, as well as easier to basically power up uh, when you need to in different locations. So that's part of the aircraft side. Then the operations side of the aircraft management is how do you manage the fleet? How do you make it affordable by having pilots to managers and so automation process that gives us opportunity to scale these operations and make it for everybody. So that's the second aspect of that. The third aspect is the airspace design. For example, do we need corridors? What kind of rules we need? What is the responsibility from the air navigation service provider, in which case FAA? What is the responsibility of operation? What kind of communication, navigation, surveillance infrastructure we need to have in place? Then airspace and operations itself. So how do you mix manned and unmanned aircraft? How do you mix eVTOLs as STOLs as well as the conventional manned aviation into the same airspace? How do you make them scalable, safe, interoperable at the same time? How do you manage the safety of those operations? So making sure that we can scale in a safe manner is fundamental to growth of these missions. And then community integration, acceptance, making sure that we know how to actually locate the vertiports and vertipads so that they will be accessible and maintain the societal needs. At the same time, we also look at the supply chain, what kind of supply chain and manufacturing backbone we need, how do you maintain these vehicles, because they're going to have very much regional operations. It's interesting to start to basically look at that complete ecosystem and say, how do I actually make sure that we are making progress on all of these simultaneously? Because as you can probably surmise that if the aircraft are ready and airspace system is not ready, or vice versa, or the community integration is fast as we would like to see. So we developed a scale originally focused on urban air mobility, UML, urban air mobility maturity level 1, which is the low density, low complexity operations that has aircraft, airspace, operational aspects, infrastructure, community, all the pillars that we talk about in general. How do we make progress on all of them simultaneously? So it starts from low density, which is the initial stage. The intermediate is the medium density, medium complexity, collaboration among operators to make sure that we can actually sustain and safely grow them. And then mature state is ubiquitous operations. So UML 6. So the idea is to make sure that we keep track of all the elements on the aircraft side, airspace side, as well as infrastructure and community. And they're evolving simultaneously to get us to that point. Our current goal by 2030 is to get to that medium density, medium complexity type operation. So that's sort of our critical commitment at the moment. A lot will depend on how fast and slow things will evolve between now and then, obviously, but that's our target. Of course, urban environment, I'll make some reference to that because it is an interesting problem in itself, because you have to operate without GPS many times. Communication could be challenging at times, and you need to find locations for takeoff and landing that are not going to hinder with other operations that happen in the urban airspace, particularly the surface traffic. And you also need to consider the local weather and microclimate to make sure that these vehicles can operate. And you've seen some, I'm sure you've seen some examples of how the experience was in New York and LA, back in 50s. The question always comes, how fast can we go? Are the localities and communities ready to adopt this? So McKinsey did this study on trying to figure out what the perception of advanced air mobility is across different countries. And you can see countries that are stressed for commute, Brazil, India, and China, they have a slightly higher acceptance for commuting purposes. Now, uh, in the United States, you see lower acceptance. There is also business aspect. So usually people see for business needs, this is going to be a good solution. Also for commuting purposes in certain locations all over the world. Um, in order for this, though, to be a serious and relevant commuting alternative or addition to the current commuting options of mass transit, this needs to be much more scalable and sustainable and affordable. And that's the part that we will be building towards, making sure that the air traffic management and airspace operations are going to be sustainable. I'll just stop here and allow you to ask questions later on. I do have to leave at 8:40 and my time, because I have another speaking engagement that starts at 8:45. But bottom line here is that we want to keep innovating in aviation while respecting its safety tradition. We do not want to take shortcuts on the safety, obviously, but at the same time, see how can we get benefit of aviation to everyone. You can almost imagine if we can get this advanced air mobility happening all over the place, there will be less need to have tremendous urbanization and having everybody locating at the central business district. You can actually live, or you can locate your businesses outside where they actually are much deserving, rather than cramming your house very close to the highways. You can spread out if you have a better alternative for commuting and transportation. There are examples like in DC where the hotel has to relocate near metro stop because commuting was not a good option for many staff members who work there. So I think we want the urban air mobility, advanced air mobility changes that paradigm, and that's the true promise that we would like to see. We can actually have much more integrated, greener living spaces if we can spread out and allow this transportation to support our needs. Thank you for inviting me again, and look forward to next speaker's presentations.
Thank you, PK. We appreciate that insight. Would like to remind all of the attendees today to put your questions in the Q&A pod so that when we get finished with the three panelists, we can entertain your questions. So with that, now we'll turn the time over to Michael.
Hello, everyone. Can you hear me?
Yes.
Okay, very good. And you can see my screen?
You can.
Okay. Well, it's great to be with everyone. It's always great to be with my friends PK and Steve, who I have worked with in the past. I'm going to talk a little bit about some of the things that are required to enable advanced air mobility and some of the policy challenges that we have to address. You know, as you heard from PK, this is a transformative airborne technology, and it's really focused on transporting people and goods in a very different way than we're used to. We used to think of it as urban air mobility, but as you heard from PK, there is a lot of benefit for providing this in a wide variety of different applications, not just in urban areas, in areas that might be underserved by aviation or might have mobility limitations that would affect how people get around in those areas. We've been talking about this for a long time. Those of us of a certain age remember a popular television show in the 1960s called The Jetsons. It was set in 2062, and it envisioned a time when we would get our news from screens, Sound familiar? That our jobs would involve pushing a lot of buttons. And again, we find ourselves in a situation where we do push a lot of buttons, and we also swipe and click as well. It also envisioned that we would be living in cities in the sky and getting around in flying cars. And we're not quite there yet. We're still very much firmly on the ground, but we are closer than we've ever been to envisioning that future that was talked about back in the 1960s. Well, what's the reason for that? Commuters spend a lot of time stuck in traffic in major cities. And that's one of the things that a lot of the technology companies and a lot of the people that are interested in this area think about. Its estimates can be as high as about 11 days of any given year that you spend stuck in traffic in major cities. And there is a belief that this market has huge potential. In 2018, Morgan Stanley Research estimated that this advanced air mobility market could total something like $1.5 trillion as the technologies are tested, as they come to market, and as people see new types of mobility that they haven't seen before. The investor interest from Wall Street and from private equity is also quite high. Over the last year, we've seen just some mind-boggling valuations on companies that are investing in advanced air mobility. You may have read that a company called Archer landed an order estimated to be $1 billion from United Airlines as part of a SPAC deal. And then more recently, Joby, which is an electric air taxi maker, went public. And you see a picture there from Forbes, in front of the New York Stock Exchange. The company has great potential and is making a lot of progress, and it really talks about the bullish nature that the bullish view that investors have on what is regarded as a pretty significant market. But there are, I'm missing a slide here. There are challenges as well, and that is that the companies are sometimes finding themselves in a situation where it's highly competitive, and they might be, there's a lot of concern about trade secrets, and there is some litigation that's going on right now between the companies as they try to ensure that they're able to protect their intellectual property and ensure that over the long term that they can be successful. I'd like to turn now to the principles of aviation safety and talk about them in the context of advanced air mobility. Aviation is founded on sort of a three-legged stool to ensure that aviation can be safe. The three elements are a certified aircraft, a certified operator, and a certified pilot. And how those get implied, or how those get applied to advanced air mobility is extremely important. Let's take the aircraft first. Most of the companies in the space are very focused right now on getting these new types of aircraft certified. The challenge and the issue that they're all dealing with is this is new, what the FAA calls new and novel technology. That means that there isn't an established standard for how that aircraft is demonstrated to be safe. And so those standards and those policies need to be developed as part of the certification process. Aviation has a long history of doing this. We moved from propellers to jet aviation. We moved from metal aircraft to carbon fiber aircraft. But the development of these standards is extremely important because what everyone wants is to ensure that the system can operate safely. There are companies that are projecting to have certified aircraft and market entry as early as 2024. In general, a lot of researchers assume that that window between 2024 and 2026 is probably when you're going to see some market entry there. So let me go back. The next is a certified operator. By that, we mean that the organization that's providing the service. And what you're dealing with here is new types of companies, effectively tech companies that will need to be certified as airlines. What that means is that a determination has been made that they have management systems in place, that they have proper training programs, that they're able to maintain their operation, and that all of it is focused on ensuring the safety of the traveling public. The third point, and in many respects, one of the most interesting ones, is a certified pilot. Aviation is founded upon a premise that when all else might go wrong, that you have an individual that is able to take command of an aircraft and ensure that it can land safely. Now, the long-term vision of advanced air mobility is autonomous flight. So effectively, you have a system that is playing the role of the pilot. And so going back to what we talked about in terms of the aircraft certification, that means that new policies and new standards need to be developed to address this question of perhaps long-term there not being a human pilot on board the aircraft. And so, clearly a lot of questions that are that need to be addressed and standards that need to be developed, but a lot of great work is taking place in all of these areas. There's also a question about public acceptance. And I think of public acceptance as falling into three buckets. While this holds great potential, I think it is fair to say that we really don't know how the public is going to respond to this. But I think that these three areas, safety, noise, and cost, are going to have a lot to do with how the public views the development and ultimate deployment of advanced air mobility. The first is safety. Now, the public has a very different view of things that fly than they do things that move along the ground. And as a result of that, we have, certainly in the United States and throughout the world, an exceptional safety record when it comes to aviation. We have a fatality rate here in the US that's virtually zero. And when you compare that to the rates of fatalities in other modes of transportation, it's quite clear that the public places a very high premium on safety in things that fly. There's been a lot of speculation as to why that's the case. I think it has a lot to do with the public's perception of control. We tend to feel that when we get in our car that we are in control, and that if there is a problem that takes place on our highways, that it's the other guy's fault, it's not our fault, that we can handle any situation that's thrown at us. Very few of us, relatively speaking, though, are pilots and are comfortable and knowledgeable about what it takes to fly an aircraft. And so we want to ensure that someone is looking out and ensuring that it's safe. And that's the role that the FAA and other regulators around the world play. And so how the public will view these new and emerging aircraft is extremely important. And I think it's fair to say that they want it to be safe. The second aspect is noise. We're at a point where we have lower exposure to aircraft noise than we have had since the 1970s. And that has been as a result of a lot of hard work by manufacturers and regulators and policymakers to bring down the noise associated with modern aircraft, to have advanced flight routes that reduce the exposure of populations to noise, that we have located airports and other aviation facilities in a way that perhaps reduces community exposure to noise. So a lot of great work has been done on the noise front. So it's interesting that public annoyance with respect to aircraft noise is at an all-time high. The public is incredibly sensitive to aircraft noise. And this is something that I think the companies in advanced air mobility really need to be thinking about. They need to, and they have been. They are focusing on developing relatively quiet electric aircraft to mitigate that exposure to noise. I think that in light of the very high public concern about noise, that this will be an issue. And the FAA is starting to think about noise standards for unmanned aircraft and for advanced air mobility as a benchmark and a baseline. But on the innovation side, I think it's fair to say that the companies have this very high on their agenda to try to develop aircraft that have as small a noise footprint as possible. The final point is cost. And what do I mean by this? Let's think about existing modes of transport. I mean, recently we've seen stories about very wealthy individuals taking trips into space, or perhaps premium services, helicopter services between downtown and major airports. Those are very expensive. And so they really don't address, the questions, and they're not really accessible to the vast majority of the population. I think part of what drives public acceptance is can a member of the public actually see themselves in the picture? If they see the development of a new service that perhaps has an impact on their community with respect to traffic or noise, but it's extremely expensive and that they don't have access to it, then they're probably less accepting than they might otherwise be. On the other hand, if it is a service that they can readily take advantage, that they can afford, that meets their mobility needs, then they will be, I think, more accepting of its existence because it's something that they themselves take advantage of. And so the way this plays itself out as the companies think of the development and deployment of advanced air mobility is how do they get that cost per mile down as low as they possibly can? Driving is relatively cheap, well under $1 a mile. And in the early days, I think that you should expect that deployment of advanced air mobility will be more along the lines of several dollars a mile. So that's not going to be widely available to everyone. But long term, the goal that a lot of companies have is to make this competitive with driving. And the technologies and the operating practices present a glide path to get there. And so I think that cost is extremely important as we think about how will the public accept this over the long run. There's also a question about roles of government, and this is an evolving area. Unlike surface transportation, aviation has been largely the purview of the federal government. The FAA is responsible for developing safety standards and ensuring their compliance. Operations are controlled at the federal level through air traffic control, and the whole funding question is largely funded at the federal level. I think as we think about longer term, the deployment of advanced air mobility, it is quite clear to me, and I think many others in the space, that state and local authorities will need to be involved. But what form that takes is something that is far from settled, and it continues to evolve. Let's take the question of land use. Everyone acknowledges that cities have an exclusive responsibility for land use, how property gets used. Under current law, the FAA has exclusive authority for regulating everything that flies once it leaves the ground. Well, how do we deal with that today? Today, we deal with it basically contractually, that the FAA recognizes a city's authority to locate its airport wherever it chooses to do so, in exchange for the city recognizing the FAA's authority to regulate the safe operation of that airport. And that construct has served us very, very well for many decades. But if you evolve to now a situation where effectively everyone's driveway has the potential to be deemed an airport, then clearly you have to think about what are the roles of the different authorities and governmental entities to figure out how they can manage that. Companies in the advanced air mobility space are split on this question. Some would like to see federal preemption and that everything would be regulated at the federal level. I think that's unrealistic. But their concern is they want to ensure that there is a level of consistency across the country in how these operations actually work. On the flip side of it, I think that state and local authorities will deal with the impacts. And what comes to mind is a point that was made by a mayor to me when I was FAA administrator. He was talking about package deliveries using unmanned aircraft, but I think the point is the same for advanced air mobility. And his point was that if I have a constituent that at all hours of the day and night is subject to impacts of their neighbors receiving packages for some home-based business, they're not going to call the FAA, they're going to call the mayor. And I need to understand what authorities I have and what we can work out so that we can balance the needs of constituents versus the needs for efficiency. And I think those are important questions. Likewise, there's the question of infrastructure, where to locate facilities that might be used for advanced air mobility, skyports and other infrastructure. And then there's a question of operations at the local level. Many cities are becoming extremely concerned about these new mobility options, whether it's bike shares and scooters, and how they might use city infrastructure, and they want to ensure that they have some means of managing that. And they're also thinking about the future development of advanced air mobility and what's the role they're going to play. So I don't think there is clarity on what that's going to look like yet, but these are important questions that need to be addressed. And then finally, a new funding paradigm is needed. Aviation investments here in the United States have traditionally been funded through a combination of user taxes and fees. By far, the largest piece of that are ticket taxes that you and I pay for commercial airline flights. Second are fuel taxes that are paid by aircraft, both commercial and general aviation. There are registration fees that are paid in aircraft, and there's a small amount of overflight fees that are collected at the federal level. These are fees that are assessed on aircraft that are transiting US airspace but not landing here. So for example, flights from Canada to Mexico. This is a model that is not readily applicable to advanced air mobility. If these are aircraft that are not using conventional aviation fuels, obviously they're not paying fuel taxes. Perhaps you can look at some element of a ticket tax or registration fees. But the bottom line is this envisions a new aviation infrastructure being developed, whether it's the traffic management system that PK talked about or the skyports that might be needed for this. And we also have to think about how we pay for this over the long run. And so, again, similar to how we have to rethink the Highway Trust Fund, the Aviation Trust Fund, as a result of these developments, is also going to require some rethinking as we deploy these new forms of air mobility. So what are the next 5 years going to look like? Well, I do believe that we will see some initial operations of eVTOL aircraft, advanced air mobility. I think initially they will be similar to existing helicopter services, but what it will give the public is an opportunity to see these aircraft in action and to imagine potential uses down the road. As these aircraft are certified and enter the market, they will initially most likely be piloted aircraft. And that will then result in companies shifting their focus toward autonomous flight. There will be a lot of dimensions to that, the technological ones that I talked about before, but also the question of the public's willingness to get on board an aircraft where there's not a human pilot on board. But it will be important to think about what that road to that looks like, primarily because it's crucial for the economics, the cost of operation that I talked about a little bit earlier. Final point is collaborative partnerships are essential. Aviation has always been founded on a principle of innovation, but it's also been founded on a principle of collaboration, that there is a lot of collaboration between government and the private sector, between the levels of government. And as we sort through the answers to these policy questions that I've talked about, those collaborative partnerships are going to be more important than ever. So with that, I will stop and look forward to hearing from Steve and then your questions later on.
Thank you, Michael. Appreciate that insight into what the future holds, both near and long term. We appreciate that. So with those comments, we'll now turn it over to Steve Kuciemba to talk a little bit more about the land side, the surface side of this conversation. Steve?
Great, thanks. And I assume you can see my slides now, Blaine?
You can.
Great. Well, good morning, and thank you all for inviting me. It's like Michael said, it's great to see old friends, folks I haven't talked to in quite a while. This is always a joy. Just like Michael, let me also start with a little bit of history. Okay, maybe more than a little. Let me go back nearly 100 years. Just a few decades after the automobile replaced the horse and buggy, visionaries started asking, what's next? Some of the examples, if you go all the way back to 1939 at the World's Fair in New York, General Motors had a diorama that depicted cars operating by themselves on a dedicated motorway. This advertisement you see me showing on my slide right here is from the 1950s. And I have to laugh when Michael showed the slide with the Jetsons. That was one of my notes I was going to talk about also, the cartoons of my youth as well. I guess, Michael, I'm in that same age bracket that you were talking about, those of us that have been able to experience those, depicting flying cars and future technology. No matter what era that you grew up in, though, future technology was always designated to take over certain routine tasks, and that includes driving. Of course, the difference is when I was younger, that was just a vision. Now it's becoming a little bit more than just a vision. If you fast forward a few more decades from the 60s and the 70s, and you get in the past 30 years, we've seen an immense amount of progress in turning a lot of those visions into reality. For example, in 1995, many of us witnessed a large-scale US DOT-sponsored project to demonstrate the automated highway system. That was really exciting. In the early 2000s, the Defense Advanced Research Projects Agency, which we know as DARPA, they had been experimenting with automated vehicles for almost 2 decades. But in the early 2000s, they sponsored a long-distance competition called the DARPA Grand Challenge that continued for many years after that. And it was a highly successful event to really accelerate a lot of the development. In fact, many of the participants from those early DARPA challenges went on to work at companies such as Google, who advanced many early versions of their driverless vehicles. You heard John Harding talk early on about some of the connectivity and the connected vehicle work. US DOT recognized early on that technology has a profound impact on what is still an expanding problem of safety on our roadways. Continuous advances have been made in vehicle improvements that would lessen the impacts of a crash. But what if technology could prevent a crash in the first place? We learned during the early parts of this century that wireless communication can truly change how we live our lives and run our businesses. So why couldn't it also provide a means for vehicles to communicate with each other or with the roadside? That would theoretically create a situation where vehicles wouldn't crash into each other. And so was born the connected vehicle concept. Let me step away from history for just a moment and take this opportunity to get on my soapbox. Those of you that know me are familiar with this issue here. Terminology is a huge issue in a nascent industry such as this. Even though we've been doing this now for 20 years, we still struggle with terminology. I already mentioned about connected vehicles and how that enables wireless communications to help prevent accidents. On the automated side, you'll hear me purposefully avoid terms like self-driving or autonomous or driverless, because those terms really can have multiple interpretations by others. And in fact, in many cases, they can over-promote or over-promise what technology can do. A vehicle equipped with sensors or software can assume part of the driving task or all of the driving tasks. It can do it in some instances and locations and maybe in other operational conditions. We're not yet at a stage where the role of the human can be completely eliminated in all scenarios. And there remains a lot of debate on, is this actually the goal or not? But I'll circle back to that point a little bit later. You'll also often hear the term CAV throughout this two-day workshop. And if you're in our business, you've no doubt have heard CAV many times. And that's what many of us transportation professionals really see as the holy grail, because it takes the best of both worlds. It allows us to combine data from other vehicles and infrastructure to complement the sensors and cameras that are on the vehicles itself. So it allows you to see and hear far beyond the spheres of your actual vehicle. And again, this is really important when it comes to safety. All right, let me come back to some more history again here. I cannot talk about connected and automated vehicles without at least acknowledging that we've been the poster child for the Gartner hype curve. You know the hype curve, it's the common graphical representation of the life cycle that technology goes through. It starts at the peak of inflated expectations, drops down to the trough of disillusionment, goes up the slope of enlightenment, and then has the plateau of productivity. There's been a lot of promises made, a lot of dates projected that haven't come fully to fruition. Many of these quotes you see here on the screen, you've all heard before. Whenever I talk to friends and family about the type of work that I do, it's not unusual that I'll get the question, well, why isn't it here yet? What's taking so long? Now, my response is usually meant to be something simple of, well, it's taking what it's taking. It needs time to ensure safety. Those of you that know me, though, I often go off on a long-winded rant about, hey, this stuff is really hard. So what is taking so long? I'm actually borrowing this slide from Blaine Leonard, our panel moderator. I saw him use it about 1.5 years ago in a presentation, and he did a great job of explaining the complexity of what we're dealing with here. This is not a singular event like so many previous revolutions in history. The move from horses to horsepower was driven by just a few companies in a time with little regulation, using known engine technology, no news cycle, amid an industrial revolution. The planets aligned perfectly for that. Speaking of planets aligning, the moon landing effort also was a very singular event. It did take the most complex machine ever built at the time, the Saturn V rocket, but it was a single effort. It was completely federally budgeted. It had a single focus of getting to the moon. Oh, and it had really strong political support too, which does help just a little bit. Take the cell phone industry, largely driven by a handful of very large companies with a clear profit motive. Even the interstate highway system, executed by 50 state DOTs, it had a clear objective, a clear plan, federal standards, federal budgets, and a public need. Very simple, very straightforward. What we're trying to do here in connected and automated vehicles is incredibly complex, and we're attempting to merge 3 very different cultures, 3 industries with different ways of carrying out their tasks. I'm most frequently associated with the infrastructure owner-operator industry from my early days working in the Maryland State Highway Administration, and I'm very familiar with the process of at least 6 to 8 years from planning to design to ribbon cutting. And that facility is expected to last 25, 50, 75 years. The auto industry, however, they'll take about 3 to 5 years generally for planning and design through production for new vehicles. And those vehicles typically last 11 to 13 years. Our newest player, however, the technology industry, these are companies that can take as little as 8 to 10 months in development for a new product that is expected to be obsolete in less than 2 years. You can see why what we're doing here is not exactly very simple. But despite not meeting some of those initial projections and dealing with a near impossible combination of paths and trying to merge all these cultures, I contend there is a lot of great activity that is still going on in the surface transportation and automation sphere. And most importantly, many of us within the industry have really started to talk about CAV not as an umbrella term, which can mean a lot of things to a lot of different people, but instead we're talking about it in specific use case scenarios. Anytime someone starts a sentence with, well, AV needs to, I'll stop them right there and say, how do you define AV? Because there are many different use case scenarios that ultimately define how connected and automated vehicles are going to play out. You see this list here, and this is probably an overgeneralized list even in itself. We could probably even dive down into further details and degradations, but really it comes down to personal automobiles, freight, transit, the transportation network companies, the robo-taxis, and some of the niche services that are out there. Starting to think about it in terms of these use case scenarios is a huge step forward for us to stop overgeneralizing and start focusing on what's important. And what is important? The benefits. Now that you're armed with a better understanding of the terminology and the different scenarios, we can take the most important step, which is reminding each other why we're doing this. The why is so important. This is not technology for technology's sake. We're trying to solve problems here. This is not a singular focus like the moonshot or switching from a horse and buggy to an automobile. Many of us have dedicated our career to advancing CAV because they can make a difference. CAVs can save lives. They can provide more access to transportation. They can improve the economy, and they can positively impact our environment. It really doesn't have to be more complicated than that. We can debate the merits of specific technologies. We can debate how they're rolled out, what business cases are explored, what policies need to change. But at the end of the day, we care about saving lives, time, and money, and improving the future of our planet. It's really that simple. We need to avoid getting into debates about SAE levels of automation or which connected vehicle technology is better than another one, and start talking about the outcomes. Oh, and if this slide has a familiar ring to some of you in the state of Utah, it's because this also was adapted from UDOT's own website. So another shout out to Blaine Leonard. Thank you for that. So as we progress into this decade of what some are now calling the new roaring 20s, we have an opportunity with CAV to move people smarter, whether it's through robotaxi, low-speed AV shuttles, transit automation, our own personal cars. Moving people using this technology is going to change how we view it. We also have an opportunity to change how we move freight, whether it's through truck automation, platooning, automating the freight middle mile, or even personal delivery devices that you're seeing on TV commercials or on sidewalks in certain cities. And yes, we even have an opportunity to address some of these key niche areas, purposes such as automated mowers, automated truck mounted attenuators, specialized agricultural vehicles, and next generation connected vehicle systems that are going to have both an immediate and a long-term impact. And of course, our purpose here today, this is a great opportunity, a truly exciting opportunity through peer exchanges like this to advance the conversation and view our future more holistically. I enjoyed the fact that Michael said on his slide that collaborative partnerships are essential. That's a lesson that we've learned also in the CAV side. It's absolutely critical. There's a lot of other lessons learned that we can share. Huge opportunities for collaboration of research, planning, integration, operations, you name it. Agencies that embrace this diversity will not only provide better outcomes for their customers, but will benefit internally by increasing the awareness of all their employees, by improving their standing when going after grants, and when assessing equity concerns for the future. Carlos said it during his opening comments that we really do care about providing benefits. We have to remember who our customers are. Well, it's going to take us thinking internally and breaking down the silos to be able to ultimately serve what our customers need. Communication, collaboration, and cooperation. It's something that I've preached for many years, and it's what's going to truly help us become future ready. So with that, Blaine, I'll turn it back to you, and I look forward to whatever our conversation and questions that we might get from the group.
Great, thanks, Steve. Appreciate that. And again, I appreciate comments from PK and Michael and Steve this morning. I will note that PK had another conflict in his schedule, and so he has left us. And so Michael and Steve get to answer all the questions. Over the next couple of days in this peer exchange, various panelists will talk about technology, policy, operations, safety, public involvement, and explore a bunch of exciting use cases for both of these technologies. As we work towards actual deployment of these new modes of transportation, I'm interested what you think are the one or two most significant challenges on our horizon. Michael, do you want to take a stab at that first?
Yeah, I think the technological aspects of it are, as strange as it sounds, the easy aspect. I think the bigger challenges are, how do we tie this to what the public thinks they need and want? I think that we often find ourselves in a place where, particularly in the technology sphere, where companies might develop really exciting new technology, and then the focus becomes very much around convincing members of the public that, hey, this is exactly what you need. Mobility is something that everyone wants, but I think that it's important that everyone really look at what is the problem that we're trying to solve. If we want to apply the technology in a way that it actually addresses people's very real needs in a way that they're able to take advantage of. And so it goes back to what I talked about before, that focusing on that public acceptance is extremely important. And that means listening to the public and kind of understanding what their needs are as part of that. The technologies will emerge. They will be certified. They will be deployed. But this acceptance by the larger public is probably the most important and most difficult point.
And Blaine, I think one thing I'll add is, I talked about collaboration and partnerships being so important. If a private company or a public agency doesn't want to collaborate with others, or they try to go it alone, we really risk missing the stated outcomes. Carlos and I are on an NCHRP project panel, and we were talking to a private company who was talking about the importance of partnerships. And they had a great quote that I'll remember forever now. And they said, it's not healthy to compete on safety. And that's really that just is going to ring with me for the rest of my career. It's not healthy to compete on safety. There are many things that companies compete on and agencies can compete on, but when it comes to safety, we really need, as an industry, to come together, break down those barriers of data sharing and information sharing and partnerships and funding, and just figure out a way to make it work.
If I could just add to that point, Steve, that's such an important point, and it's a lesson that commercial aviation started in the 1990s, where it's now evolved to a point where airlines in the aviation industry generally broadly share information related to safety across all of their peer companies. And I think that this whole idea of ensuring safety is so important, and it is something that we want to apply as broadly as we can across all of transportation.
Right. So I want to dive in a little bit on the public. Michael, you in one of your slides showed some of the public issues, right? Safety, noise, and cost. Steve talked about the benefits, the public benefits, and how to achieve those. And Michael, in response to this first question, you sort of said that the biggest hurdle will be the public. And I think that makes perfect sense. The question is, how do we deal with that? So what advice do you have for someone like me who's in a state agency, or some of our attendees who are in maybe local agencies, working on some of these technologies, on how we should deal with the public, involve the public, engage with the public in a way that overcomes this barrier? What are the mechanisms, the tools, approaches that would be effective here?
I would say two things. The first is no surprises. You do want to talk a lot about what it is that you're trying to accomplish. I would also recommend starting small. And what do I mean by that? It's virtually impossible to deploy widespread advanced air mobility all at once, but give a lot of thought to what those initial use cases would be, so that it's, as I think about many of my friends in the unmanned aircraft industry, some of the early use cases might be associated with, delivering carry-out food. Well, that's interesting. It demonstrates the technology, but other use cases have been focused on delivering critical health supplies. And I think that kind of a use, where everyone understands the benefit, everyone understands the importance, and what this represents in terms of being able to do things more quickly, to provide more secure types of services, and it saves people's lives, that it tells a very compelling story. So I think that a lot of communication and demonstration, but in ways that help members of the public see the potential of why this is beneficial to society, is really important.
And that's something on the surface side that we're just finally coming to grips with, and I don't know that everybody has come to grips with it yet, and I mentioned that during my talk about you just can't use the umbrella term AV. You've got to really dive down into more of the specifics, because there are some really immediate benefits and immediate scenarios that make sense today, instead of getting hung up on, well, is that car going to be driving down the freeway next to me and that makes me uncomfortable? Well, that may be 25 years from now, but tomorrow, this truck that could deliver goods from warehouse to store, and help a driver shortage right now and get your goods to you faster, that's an immediate benefit. It's an immediate economic benefit. And we need to just keep focused on the use cases as much as possible.
Great, thank you. So we only have a couple of minutes left. I've got several questions I'd like to dive into, but we obviously can't, including a couple of good questions from some attendees. Let me maybe end with this one. The goal of this peer exchange, and it's kind of a unique peer exchange, is to bring together the surface people and the air people with two very innovative technologies that haven't really met very often, right? And to try to find the intersection between these two technologies. So I guess my final question here is, what is the opportunity? What is the overlap? Where is the common ground between CAV and AAM, where we can come together and work together and help each other out? A 30-second response.
Michael, go ahead and go first.
This is something I have been struggling with my entire career. When I was, running the intermodal transportation office at USDOT way back when, they are very distinct universes. And, most recently I've been in aviation, where we have our own language. We talk about TRACONs and ARTSIs and PBN and all of these things that absolutely make no sense to anyone in the traveling public. But at the end of the day, it's all about mobility. I think that if we're focusing on how can we move people most efficiently and most effectively, that, I think becomes a very compelling narrative. There are things that reinforce the separation. We have very distinct funding streams. We have very distinct regulatory schemes, but there is nonetheless a lot that can be learned from one side to the other, whether it's sharing safety data, whether it's operating practices, whether it is costs associated with providing the service. And we've really got to, particularly as we think of AAM and CAV, where the two domains, aviation and service transportation, really overlap in ways that they haven't before. It's very important that we be intentional about how these two areas can work together.
Thank you, Michael. We're about to turn it to Pumpkin here, but Steve, any parting thoughts on that question?
Again, I think sharing lessons learned, sharing outreach opportunities, breaking down some of the silos within organizations, looking for opportunities to get on each other's stage. A lot of state DOTs or regions have CAV working groups. Well, invite the AAM folks to come to those working groups. As you're setting together your strategic framework for the future, bring AAM into the conversation. And think about outreach means a lot of different things to a lot of different people, but there are opportunities. If you're communicating with the public on the surface side and the air wants to do it, why not combine them and get as much bang for your buck as you can to get the word out there to educate the public?
Great, thank you. Well, I want to thank both of you, Michael and Steve, and PK, who's not with us here, for a great conversation, a great discussion, and really teeing off the next 2 days of this conversation. Thanks for your time. Thanks for your insights, and we'll carry on from here.